Hi and welcome back. In this video, we are going to look at how to implement the single linked list. So we'll write the code in the Visual Studio IDE that how to implement the single linked list, right? So in the previous videos, as I have told that in this series of data structures and algorithms, I'm not going to make you understand or explain anything from the scratch. But what I will do instead, I will provide you with the code, okay? So what I expect from you is that if you come here, then you should have basic knowledge about the topic. Okay. So for example, in this video, I'm going to explain that how to implement the single linked list. So you should have some kind of knowledge about the single linked list, right? But don't worry, I will also give you a summary for your revision purpose about the topic, right? And so that you can connect the theory and the coding part also. Okay, so let's get started. So in this video we'll quickly look at the summary part of the single linked list, and then we'll move on to the Visual Studio IDE to implement it. Okay, so let's get started. Okay, so with that said, let's first discuss quickly that why do we need linked list. I know that you may be knowing this stuff if you have learned the some basic of the linked list. Okay, so there are mainly 3 points. First point is that array are contiguous blocks of memory, right? So as we know that array array are contiguous blocks memory. So what does that mean? That means if you see the image on the right side, what it says that we have a linked list versus arrays, and we are comparing linked list versus arrays on the basis of the dynamic memory allocation, that how the memory is allocated for the array and how the memory is allocated for the linked list. Okay, so if you see the array, the memory allocation for the array is done in contiguous fashion, the space for each and every element inside the array will be in contiguous manner. So here in this image, what I have done is that I have allocated the memory for four array with one array with four integers in it, right? Okay. So this memory has been allocated in the contiguous fashion, right? But in the case of linked list, you can see that the memory has not been allocated in a contiguous manner. So one node has been allocated here, next one is allocated here, next one is allocated here, and so on, right? So that like insertion and deletion becomes very expensive in the case of array. Let's move forward quickly. So here is the basic or the image of the single linked list. This has head pointer which always points to the first node of the linked list, and each node of the linked list has two parts. First is the data, and next is another is the next part. Next part stores the address of the next node, right? Okay, so so this is the data type for the node. As we know that node has two parts. First is to store the data, and second is to store the next. So first part may be integer, character, float, and the next part will be the pointer, right? So we need structure to have this kind of property. Okay, so first is the int data, that means it will store data, and second is the it will store the next or the address of the next node, right? That's why it's a pointer to the struct node, right? Okay, so how to dynamically allocate the node? So so let's come back. Okay, so first we need to define a temporary pointer, which is temp in this case, and then we'll use the struct node sum malloc size of this is the dynamic memory allocation as usual we do. Then we'll put the next as null, because if we are not connected, we are not going to connect the node yet. It's isolated one, right? Okay, and then after that we are going to feed into the data part with value some value x, right? So this is single linked list. Now if you see the okay, so this is some more elaborate part of the single linked list. Here same we have a single linked list with addresses are written here. So head will point to the first node. This 300 is the address of the next node, right? So each node has two parse data and the next, and this is the structure for defining node. And the type of linked list, just to remind you, there are three types. First is the single linked list, second doubly linked list, and third is circular linked list. Okay, and this we have discussed earlier also. Okay, so let's move forward. Now we'll just quickly see that how to traverse the linked list, because it's very important to see that how to traverse the linked list. Okay, so let's consider a temporary pointer p which is initially pointing to head, right? So head is pointing to the first node of the linked list. That means head is storing the address of the first node of the linked list, right? So I am copying this value to a temporary pointer p, which means that now p is pointing to the first node of the linked list, right? Now to traverse the linked list, what we need to do is that we need to change the value or change the address inside the p to from a to b, right? So how we can do that? We can do that by assigning this value. So p equals to star p dot next. So what I am doing is that, so at first p is pointing to here. That means let's say the address of node a is 200, then the value of p is 200, right? And the address of b is 300, then the next here, so the here the value will be 300, right? So if you do p equals to star p dot next, then the 300 will be stored into p. That means the p will move here, right? If you again do the same, p equals to star p dot next, then again it will move here. If you do again p equals to star p dot next, it will again move here. You do again p equals to star p dot next, then it reaches null, right? So this is how you traverse the linked list. Okay, fine. Fine. Now let's go to the Visual Studio IDE quickly and we'll write the code. Okay, so let's move on to the Visual Studio IDE. Okay, so let's just finish off this. Okay, so I'm going to implement this in C++. So let's just quickly write the code. I less than n. What I'm going to do is that I'm going to define one element and then I'm going to take that element, okay, and then call in. Okay, so call, let's say create. Okay, create list is the function. Okay, so before that, now we need to define the structure, defining the structure for the node. Okay, so what it will be, as we have discussed in the video, that it should be struct node, and inside that I'm going to fit the data part, right? And next will be to store the address of the next node. Okay, so this is the data type of the node, which is a structure. So inside the structure we have two parts. First is to store the data and second is to store the address of the next node, right? Okay, now we are going to define one pointer which will be head. Okay, so initially head is pointing to null. So what is head here? So head is the pointer which always points to the first node of the linked list. Okay, so I'm going to pass head and I'm going to take the return value as head. So I'm going to pass the head and simultaneously the element to be inserted. Okay, and then I'm going to defining the function to insert the node. Okay, so basically in this what we are going to do is that we are going to insert the node at the end. Okay, so we'll discuss that what is the code to insert the node at the beginning, at the after a given node, right? But in this case we are going to insert the node at the end for our simplicity. Okay, so at the end. Okay, and the return type of the function will be what? Yes, so I am taking the return value into the head. So head is a pointer, right? Pointer to the structure. So it should be what? It should be pointed to the structure only. So struct node, right? And so let's write the actual function here. It should be this, and the function name is create list, and the parameters are like this. So struct node star head, and I am taking element as a parameter. Okay, so the first case will be that if the list is empty, that means the head is pointing to null, right? So in that case we just need to define a new node and you just assign the address of the new node to the head, right? So first let's first define the new node. First defining the new node. Okay, so before that I am going to do, okay, so struct node star temp is equals to null, and you do temp is equals to new. Okay, so struct node, right? Now it has been allocated. Now you just do start temp dot data is equals to element. So I have updated the element, the data part of the temp, and then I'm going to do start temp dot next is equals to null, right? So by this way I have allocated the memory for the node, and I have also feed in the value or value into the data part. Now we want to insert it into the linked list, right? So how to do that? So applying if statement. So if the head is null, okay, so if head is null, what does this mean? Okay, so this means that the list is empty, right? So for that, what I'm going to do is that I'm going to assign the value or the address. So what is temp? So temp is the pointer to the new node, right? That means the temp has the address of the new node. So assign the address of the new node to the head. Now the head is pointing to the first node of the linked list, right? Okay, so if the list is not empty, okay, then we need to go to the last element of list, right? So let's do that. So how we can do that? So for that I am going to define another temporary pointer, let's say b, and I'm going to assign the value to the head. Now this is pointing to the first node of the linked list. Okay, now I am going to traverse that. Okay, when I'm going to traverse until I reach the last node. So this is the condition in the while loop to reach the last node. You just figure it out that why is this so. Okay, I'm not going to tell you everything because I'm giving the code also, and I'm explaining a bit also. So it's your task to go through the code and understand that why I am doing like this. Okay, it may be difficult to you to understand this code at the first instant, but try your best to understand this code. Okay, so let's continue. So as we have discussed in the in this video, in the summary part, that how to traverse the linked list. Okay, so this is what I am doing, that I am traversing the linked list until I reach the last node. Okay, so once I reach the last node, then I am going to update the address part of the last node from null to temp. Okay, by this way I have inserted a node at the last. Okay, and finally I'm going to say everything went fine, and just you return from here, right? This is what I have done. Okay, so this was my function which is to create the list. Okay, so let's go through it once again. So I have allocated the memory to get the new node. Then this if block taking care the condition. If the list is empty, then we just need to assign the address of the temp to head. That means head equals to temp. If you do that, then head will then the node will be inserted into the linked list. Okay, if this condition is not there, okay, so here also we need to write return. Okay, if the list is not empty, then we need to first reach to the last node. This is what I am doing with the help of while loop. I am reaching to the last node by using the concept of traversal of the linked list, which I have discussed in the summary part, and I hope you also know that. And finally, once I reach at the last node, then I am assigning the address of the new node to the next, or address of the new node to the next part of the current node, right? Okay, so this is how you do. Now let's quickly just print this. So printing the list using the function. So how I am going to print? I am going to again use the same concept of what? I am going to use the same concept of traversal. Okay, so do note that as the return type of the function is struct node star, so we need to return the updated head here. Okay, not just return. It will be wrong because the head is updating at every stage, right? Okay, now coming here, let's say print list. Okay, so inside that what I'm going to pass is just a head. Okay, and let's just define that function. try by yourself to write this code. Okay, so defining the function to print the list. Okay, again the return type of the function will be the void type. Okay, okay, uh, yeah, so void print list, and the parameter is like this. Okay, now what I'm going to do, if the head is equals to null, then we need to just return, that means the list is empty, right? You just return. Otherwise we need to use the concept of traversal of linked list again. That means traversal means we'll use the concept p equals to star p dot next, right? So using the while loop, before that I'm going to define the temporary pointer here, okay, which will point to the head, and then using the while loop, and this time the condition will be while p is not equals to null. Okay, please make sure that you understand the condition of the while loop. I'm not going to explain that. I'm going to just say that look, this is the condition to print all the stuffs present in the list. Now you figure it out by yourself that how to do that. Okay, 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 so as of now let's just see out it. So how I am going to do is that I'm going to do star p dot data, and I'm going to add some space into that, and then you do the traverse of it. Okay, so star p dot next. By this way you will be able to print the linked list, and finally you do indel and do say everything went fine, right? Okay, so everything went fine, and you just return from here, right? Yeah, so our code is completed. Now again I will do the same stuff like return 0. Now I'm going to save it and we'll just compile it. So okay, so just go to C++. Now you do G++ here, G++ minus o, what is the name is link.c. okay, so link.cpp. So as you can see it is giving some error. Let's look at the errors. Okay, so it has some kind of use error here. Okay, so I think I have defined something wrong, some spelling mistake. Yeah, okay, now let's again do the same stuff here. Where is my terminal? Yeah, so I am going to again compile. Okay, so it is terminating, right? Let's see that in which file it is there. So C programming C++, it's link.cpp, right? So G++ minus o link.cpp. Okay, it has compiled successfully. Now we'll just run it. Okay, so it's not doing this stuff. Let's try another. Yeah, so it should ask the value. Okay, so it is asking that enter the value of the number of nodes. Let's say I entered 5. Now I will enter the elements 1 2 3 4 and 5. You can see I have printed the list. Again you check, I will insert only one node and the value of that should be 10. 10 has been printed. Now again I will insert 0, then nothing has been printed. Okay, so I think you have understood that how to print the linked list and how to create the list. So this is the whole code. Okay, please go through it and please try to understand. Okay, okay, fine. Okay, so I hope you have understood this completely. Again I am reminding you that if you want the code of the data structures and algorithms, then you are at the right place, and at the right playlist. Okay, so if you want the code of the data structures and algorithms, and also you want a proper implementation of the various data structures and all the algorithms, then you are at the right place. So please subscribe the channel and please like the video, and that's it for this video. Thank you and Jai Hind.